Today we're going to be looking at the conservation of energy in a system of conservative forces. So let us first define what we mean by a conservative force. So a conservative force is any force for which, just delete that and rewrite it, because for which the work done by that force in moving a particle between two points is independent of the path taken. So an example of a conservative force is weight. If you lift a weight up, the work done lifting that weight up it doesn't matter how you lift that weight up. It's just the initial height into which it the initial and the final position that weight is in, which determines the work done. But friction and driving force are not conservative forces. When work is done by a conservative force, it changes stored potential energy into kinetic energy with no loss of mechanical energy. That energy can be recovered again as the potential energy is then transferred back into kinetic energy. This is the principle by which hydro pump storage systems work. So if you have, for example, say you have a mass of water down here and you've got a mountain, you can pump that water up. So you've got your water, you pump it up, so you've got your kinetic energy and it's stored up here. Then when you need it, you release it again, so that potential energy is then converted back into kinetic energy. Therefore, as a consequence of the work energy principle, that is for a closed system of conservative forces, the total mechanical energy kinetic energy plus gravitational potential energy is constant. So this means if we have the initial kinetic energy plus the initial gravitational potential energy, that will equal the kinetic energy at any point plus the gravitational potential energy at that same point is going to be equal to the final kinetic energy plus the final gravitational potential energy. Alternatively, we can think of that as being the loss in gravitational potential energy is equal to the gain in kinetic energy, or vice versa. The gain in gravitational potential energy will equal the loss in kinetic energy. We call this conservation of mechanical energy. So let's look at a couple of examples of this at work. A box of mass m kilograms is initially at rest. It slides down a smooth slope that is inclined at 30 degrees to the horizontal. Find the speed of the box after sliding a distance of 3 meters. So we can ignore friction because it states it's a smooth slope, and air resistance. So the gravitational potential energy plus the kinetic energy is constant. So the increase in kinetic energy is going to equal to the loss of gravitational potential energy. So it's got m kilograms, and it's initially at rest and it slides down the small slope. So we've got our change in kinetic energy is going to be v squared minus u squared, and that must equal the loss of the gravitational potential energy as it goes down the slope. So it's got a gravitation. If you think about our slope here, and this is 30 degrees, our box up here has no kinetic energy, but it's got gravitational potential energy. But down the bottom, when it comes to rest, when it comes down to the bottom here, it's lost its gravitational potential energy that it had here. So we have, so this is going to be 0, so it's going to be half mv squared, or we can take away the m's, they can get cancelled, they'll cancel each other out, is going to equal gh. Now what is h? So let's think about the height. Now it goes down 3 meters. So we can use the sine rule to find, we can find out using the sine of 30 is the h over the hypotenuse, so h will be 3 sine 30, so h is going to be 1.5. So v squared is going to be 2 times 10 times 1.5, that's meters. So v will be the root of 20 times 1.5, which will equal 5.48 meters per second. Let's do another one. A ball of mass 0.05 kilograms is thrown vertically upwards from a height 1.5 meters above the ground. The ball rises through a height of 2 meters to reach a maximum height of 3.5 meters above the ground. Use conservation of mechanical energy to find the initial speed of the ball. So there's no mention of any kind of air resistance, so we assume that it is a closed system of conservative forces, therefore we don't need to worry about friction or air resistance. So we're going to say the initial speed is u meters per second. So we're going to find, so the gravitational potential energy plus the kinetic energy equals a constant. So we're going to measure the heights from ground level. So the initial gravitational potential energy is mgh is 10, the mass is 0.05 times 10, and the height is 1.5. So that will give us 0.75 joules. The initial kinetic energy is half m, which is, we'll just half times 0.05 times u squared joules. Now we want the final gravitational potential energy, which is going to be 0.05 times 10. Now the final height is 3.5, which is 1.75 joules, and the final kinetic energy is going to be 0 joules, because it comes to the final speed is going to be 0 when it's at its maximum height. Hence 0.75 plus this here, so that's half of 0.05 is 0.025, u squared is going to equal 1.75. And so 0.5 u squared is going to be 1. So u is going to be 6.32 meters per second. So I hope that makes sense.